Alright, so now we're going to talk about coterminal angles, and I've hinted at this a little bit, but now we're going to formally define it. So co, that's our prefix. It means usually like with or together, and then terminal, we're talking about the end, so the terminal side of the angle. So this is angles with the same initial and terminal sides. Again, just for what we do in this class, we're going to be talking about angles in standard position. So what does this look like? So I have this arbitrary angle here. Here's our initial side. And let's say this angle here. So I'm just going to make this up, and let's pretend, and I'm just going to use degrees for right now. Let's say that this is 225 degrees. Okay, great. Positive angle, looks good. Third quadrant. Okay, well, what if I start at the same initial side but go negative? All right, well, what's that? Well, let's say that's negative 135 degrees. So, sorry, not sure why that did it. These are coterminal angles. What are other examples? Well, we could take the same initial angle, right? And what if I do an extra spin? Okay, so now this is going to be 585 degrees. And we could do the same thing going the other direction, right? So I could have start here and go this way. And so this would be negative 495 degrees. So these are all coterminal angles. So how do we find coterminal angles? Great question. Well, if I have an angle in degrees, then I'm going to add or subtract 360, or a multiple of 360. If I have an angle in radians, then I'm going to add or subtract 2 pi, or a multiple of 2 pi. Now you may or may not have seen this notation before, where we do like a number times n. Here 2 pi times n. N is just representing an integer. So that's why we can say like 360n or 2 pi n, because it could be, you know, if n is 7, then it's 360 times 7, and we're going to add or subtract that to the theta. Or here, if n is 7, then it would be 14 pi, and we're going to add or subtract that to theta. The point is you can keep going around a circle in either the positive or negative direction, and as long as you are starting and ending at the same location, that is a coterminal angle. If you want to think about this from like a spinning perspective, figure if you were to stand and look at the same point and then spin around and look at that same point again and then spin around and look at that same point again, every time you do that you're creating another angle, or the amount of times you spin you're creating a bigger angle depending on the direction, it's positive or negative, but you end up in the same terminal location from the same starting location, so those are coterminal angles. Okay. So, I want you to try and determine 2 coterminal angles, one positive and one negative, for each of the following angles. If the original angle is in degrees, I want you to stay working in degrees. If the original angle is in radians, I want you to stay working in radians. There are an infinite amount of correct answers for these. I want you to try and do all 4 of them. Pause the video, unpause when you're ready to check your work. Alright, so hopefully for negative 20 degrees, if I add 360, I get 340 degrees. If I subtract 360, I get negative 380 degrees. These are 2 correct answers. Remember, we're looking for one positive and one negative. Okay, so here's a positive answer, here's a negative answer, but I could continue to add 360 or continue to subtract 360 from either of these answers to get more positive or negative coterminal angles. For 3 pi over 7, okay, so this is in radians. I want to add or subtract 2 pi. So the very first thing I did, notice off to the side, I thought to myself, okay, well, this has a denominator of 7, so what is 2 pi but with a denominator of 7? That is 14 pi over 7. So 3 pi over 7 plus 14 pi over 7 is 17 pi over 7. 3 pi over 7 minus 14 pi over 7 is negative 11 pi over 7. again, here's a positive answer, here's a negative answer. I could continue to add and subtract 3 pi. I could continue to add and subtract 2 pi, which is 14 pi over 7, if I wanted more answers. That actually comes up with 420 degrees. So with 420 degrees, first I added 360 until I got 780 degrees. Then I subtracted 360 and I got 60 degrees. So both of these are positive coterminal angles, right? I need a positive and a negative. So what I need to do is I need to take the 60 degrees and subtract 360 again. And so I get negative 300 degrees. So here would be a negative coterminal angle. Again, I could keep adding or subtracting from these to get other coterminal angles. I did a similar thing with negative 11 pi over 3. So similar to the other radian problem, I first figured out, well, what is 2 pi with a denominator of 3? That is 6 pi over 3. So then I take a negative 11 pi over 3 and I add 6 pi over 3. That's negative 5 pi thirds. And then I take negative 11 pi over 3 and I subtract 6 pi over 3. And that's negative 17 pi over 3. So now these are both negative coterminal angles. I need a positive coterminal angle. So I'm going to take the smaller negative that I found. Sorry, that was my dog shaking. And that's negative pi over 3. And I'm going to add 6 pi over 3. And that's pi thirds. So here is my positive coterminal angle. Again, I could add 2 pi or 6 pi over 3 if I wanted to find a different answer.